In question number 16, a prism has refracting angle of 60 degree, that is A is equals to 60 degree. It is when placed in position of minimum deviation, the deviation produced is 30 degree. That means minimum deviation is 30 degree. We want to find the angle of incidence. For minimum deviation condition, the angle of incidence is given by A plus delta m by 2. That is equal to 60 plus 30 by 2. So angle of incidence will be 45 degree. So option 2 is correct option. In question number 17, the angle of prism is given 60 degree. The refractive index of the material is root 2. So mu is equals to root 2. We want to find the angle of minimum deviation, that is delta m. The refractive index is given by sine of A plus delta m by 2 divided by sine of A by 2. So mu is root 2 multiplied by sine A by 2. A is 60 degree, so sine A by 2 will be sine 30 degree is equals to sine of 60 plus delta m by 2. Sine 30 is 1 by 2, so this will give us answer 1 by root 2 is equals to sine of 60 plus delta m divided by 2. But sine 45 degrees 1 by root 2, so we can write 45 into 2, that will give us answer 90 is equals to 60 plus delta m. So minimum deviation will be 30 degree. So option 3 is correct option. In question number 18, the refractive index of the material of the prism is root 2 and its refracting angle is 30 degree. One of the refracting surface of the prism is made mirror inwards and a beam of monochromatic light enters the prism from the another surface and the ray retraces from the mirrored surface. To retrace its own path, this ray should be incident normally on this mirror. So angle between mirror and this refracting ray should be equal to 90. We want to find the angle of incidence. Here in this triangle, if this angle is 90, this angle is 30, then this angle will be 60 degree. So angle of refraction will be 30 degree. We want to find angle of incidence. So we can apply Snell's law at this point of incidence. That is sine I is equals to root 2 sine r. Angle of refraction is 30 degree. So sine I is equals to root 2 into 1 by 2. That will be 1 by root 2. So angle of incidence will be 45 degree. So option 2 is correct option. In question number 19, a glass prism of refractive index 1.5 is placed in water of refractive index 1.33. We want to find the minimum value of angle of prism A, so that it would not be possible to have any emergent ray. There is no emergent ray, that means it is incidenting at the critical angle. So the critical angle is given for the glass water situation is sine C is equals to mu rarer, that is 1.33 upon mu denser 1.5. It is approximately 62.5 degree. So the angle of prism will be equal to 2a. A will be equal to 2 of theta c, that is 2 into c. That will give us the answer 125 degree. So option 2 is correct option. In question number 20, an equilateral prism, that is A is equals to 60 degree, of refractive index 5/3 is immersed in water of refractive index 4/3. A ray of light passing through the prism undergoes minimum deviation. Then we want to find the angle of incidence on the first phase. Here mu is given by sine I upon sine r. For minimum deviation, r will be equal to a/2 and that is equal to 30 degree. Mu will be relative refractive index, that is 5/3 divided by 4/3 is equals to sine I upon sine of 30 degree. So 5/4 into sine 30 degree, that is 1/2 is equals to sine I. So sine I is equals to 5/8. So angle of incidence will be sine inverse of 5/8. So option 1 is correct option. In question number 21, a ray of light passes through an equilateral glass prism, that is A is equals to 60 degree, such that angle of incidence is equals to angle of emergence. And the angle of emergence is 3/4 times the angle of prism, that is equal to 60 degree. So E is equals to 45 degree and that is equals to angle of incidence. We want to find the refractive index of glass prism. Refractive index of glass prism is given by sine of A plus minimum deviation delta m/2 divided by sine of a/2. Here we can use this formula because it is given that I is equals to E, so deviation will be minimum. That deviation can be written as delta is equals to I plus E minus E. I and E both are 45 degree, so that will give us 90 minus 60 is equals to 30 degree. So mu is equals to sine of 60 plus 30 divided by 2 divided by sine of 60/2, that is 30 degree. This will give us answer sine 45 degree, that is 1/√2 divided by 1/2. So mu will be equal to √2, that is equal to 1.414. So option 2 is correct option. In question number 22, ACB is right angle glass prism of refractive index 1.5. The angle A is 60 degree, C is 90 degree and B is 30 degree. A thin layer of liquid is on AB side. For a ray of light which is incident normally on AC, so this is 90 degree, so it will enter the prism without refraction to be totally reflected at AB. So there should not be any refraction through this medium. It should be completely reflected in this medium. We want to find the refractive index of liquid. Let's say it is mu dash. Here if this angle is 90, this angle is also 90. This is 60, so this angle will be 30 degree. So angle of incidence here is equal to 60 degree. Here it should act as the critical angle for this interface, so we can write mu sine 60 degree is equals to mu dash sine 90 degree. So mu is 1.5, that is 3 by 2, into sine 60 degree, that is root 3 by 2, is equals to mu dash. So mu dash is equals to approximately 1.3. So option 3 is correct option. In question number 23, the principal section of a glass prism is an isosceles triangle ABC with AB is equals to AC. The face AC is silvered. A ray of light is incident normally on the face AB, and after two reflections, this is first reflection and this is second reflection, it emerges from the base BC perpendicular to the base. We want to find angle BAC of the prism. Here from the figure we can see this angle is I1, then this angle will also be I1 as this surface is mirrored. This is perpendicular. Let's say this angle is beta and this angle is alpha. So from the figure we can write that I1 is equals to, this angle is 90 degree, this is prism A, and this angle will be 90 minus I. So I1 is equals to 90 minus A. So this will be equal to A. Now alpha is equals to 90 degree minus 2I1. From this we can write alpha is equals to 90 degree minus 2I1 is equals to 90 degree minus 2A. So I2, this angle is I2, it can be written as 90 degree minus alpha, that is equals to 2A. Now beta can be written as 90 degree minus I2 is equals to 90 degree minus 2A. Now from the geometry of figure, this angle is 2A, this angle is 2A, and this angle is A. So 2A plus 2A plus A is equals to 180 degree. So 5A is equals to 180 degree. So A will be equal to 36 degree. So option 2 is correct option. This was question number 23. In question number 24, a prism is made up of material of refractive index root 3. The angle of prism is A. The angle of minimum deviation is equal to angle of prism. We want to find the value of A. Mu is given by sine of A plus delta m divided by 2 divided by sine of A by 2. So mu will be equal to sine of delta m is also A. So this will be A plus A by 2. That will be sine A divided by sine of A by 2. Sine A can be written as 2 sine A by 2 into cos A by 2, that upon sine A by 2. This will get cancelled out. So cos A by 2 will be equal to mu by 2. Mu is given root 3, so that will be equal to root 3 by 2. So A by 2 will be equal to 30 degree. So angle of prism is equals to 60 degree. So option 3 is correct option. In question number 25, we want to find the maximum value of index of refraction of material, that is mu max, which allows the passage of light through it when the refracting angle of prism is A. The refractive angle is given A. Here, to allow the passage, the maximum angle of incidence on the second surface should be equal to critical angle. And for minimum deviation, R1 is equals to R2. So this R1 should also be equal to critical angle. So R1 is equals to R2 should be equal to C. R1 plus R2 is equals to C. So is equals to A. So we can write A is equals to 2C and critical angle C is equals to A by 2. Now the refractive index is equals to 1 upon sine of critical angle, that is equals to 1 upon sine of A by 2. So mu will be equal to under root. Simplifying this according to the options, so we can write 1 is equals to sine square A by 2 plus cos square A by 2 upon sine of A by 2. So mu is equals to under root, squaring it inside the root, the sine square A by 2 and sine square A by 2 will get cancelled out. So 1 plus cos square A by 2 upon sine square A by 2, that will be cot square A by 2. So option 4 is correct option. In question number 26, a beam of monochromatic light is incident at angle I is equals to 50 degree on one face of an equilateral prism. The angle of emergence is 50 degree. The angle of emergence is 40 degree. We want to find the angle of minimum deviation. Here the prism is equilateral prism, so A will be equal to 60 degree. Delta is given by I plus E minus A. So delta will be 50 plus 40 minus 60 degree. So delta will be equal to 30 degree. So at this particular case, delta is given 30 degree. In the graph, it is given that for the value of I 40 degree and E 50 degree, the delta is something more than delta minimum. So delta minimum will be less than 30 degree. So option 2 is correct option. In question number 27, a certain prism is found to produce a minimum deviation of 38 degree. It produces deviation of 44 degree when the angle of incidence is 42 degree or 62 degree. That means if angle of incidence is 42 degree, then angle of emergence will be 62 degree and vice versa. We want to find the angle of incidence when it undergoes minimum deviation. Delta is given by I plus E minus A. For delta is equals to 44, I can be taken as 42 plus 62 minus A. From this we can find that A is equals to 60 degree. Now we want to find at what angle of incidence the deviation will be minimum. So minimum deviation is equals to 38 degree. At minimum deviation, I and E will be equal, so we can write it 2I minus 60 degree. From this we can conclude I is equals to 49 degree. So option 2 is correct option. In question number 28, a light ray is incident on a prism of angle 60 degree and refractive index √2. The angle of incidence at which the emergent ray grazes the surface. The angle of incidence we want to find given the emergent ray grazes the surface. If this is the incident ray, this is angle of incidence at this point. The emergent ray grazes the surface. That means the angle of refraction R2 should be equal to the critical angle C. Here it is given that sine of 15 degree is equals to √3 minus 1 divided by 2 √2. The angle of emergence will be 90 degree. So applying Snell's law at this point, we can write √2 sine R2 is equals to sine 90 degree. So sine R2 is equals to 1 by √2. So R2 is equals to 45 degree. Now R1 plus R2 is equals to 60 degree. So R1 will be equal to 60 minus 45 degree, that is equals to 15 degree. Now applying Snell's law at the first surface, sine I is equals to √2 sine R1, that is equal to √2 sine of 15 degree. So sine I is equals to √2 sine 15 degree is given √3 minus 1 divided by 2 √2. This √2 will get cancelled out. So I will be sine inverse of √3 minus 1 divided by 2. So option 1 is correct option. In question number 29, the figure shows a mixture of blue, green and red color incident on right angled prism. This angle is 45 degree. These rays are coming parallel to this side. So they will be incidenting on the surface all at angle of 45 degree. The critical angle for red color is 46 degree. The critical angle for green color is 44 degree and critical angle for blue color is 43 degree. Here green and blue have critical angle less than 45 degree. So green and blue are incidenting at an angle more than critical angle. So there will be TIR, total internal reflection of these two, and red will pass from the prism. So red will be separated from green and blue. So option 1 is correct option. In question number 30, two prisms are combined as shown in figure. We want to find the total angular dispersion and angle of deviation suffered by the white light. Here angle of prism and refractive index for violet and red color for both the prisms are given. We want to find the angular dispersion and angle of deviation. The total angular dispersion theta total will be equal to theta plus theta dash, and theta is given by mu v minus mu r into a. So theta total will be 1.5 minus 1.4 into 4 minus 1.7 minus 1.5 into 2. So theta total will be 0.8 degree. The total angle of deviation delta t will be delta plus delta dash, and delta is given by mu v plus mu r divided by 2 minus 1 into a. So delta total will be delta, that is 1.5 plus 1.4 divided by 2 minus 1 into 4 degree plus, this will be plus 1.7 plus 1.5 divided by 2 minus 1 into 2 degree. Simplify this, we will get delta total is equals to 3 degree. So the total angular dispersion will be 0.8 degree and total deviation suffered by the white light will be 3 degree. So option 1 is correct option.